Hi class, we have the third lesson for height and distance. See the triangle we have here. Of course, lesson 1 and lesson 2, we are so easy and straightforward, but we've started upgrading. So just be focusing and patient enough so that you can go according to the order of the videos. Here is a triangle, but this triangle is 90 degrees. Here, specifically, it's a triangle, but it's not a right angle triangle because this angle is not up to 90. This angle is more than 90. This angle is less than 90. So 1, 2, 3, none of the angles in this smaller triangle is up to 90. So that makes it a known. It is not a right angle triangle. But this one down here is a right angle triangle because one of its angles is 90 degrees. This one. Here is 25 meters. Here is x, the shorter side at the top there. We want to find the length of this x. But when you consider that side of the triangle, here is 10, here is x, you cannot get x. There is no way you can get x because we don't know this, we don't know this. So even if we know this one, we cannot still get this one. Why? Because this is not a right angle triangle. Wherein you can think of the opposite side, the adjacent side, the hypotenuse side. Not a right angle triangle. So what exactly do we do? This is the only one we want. But specifically, this triangle has here 40 degrees. The smaller one here is 10. But if we assume that there is no line here, what do you think will be this angle? It will be 50. Why? Because here is 10, here is 40. Put together, there will be 50. Remember, we are assuming that there is no line that passes through them. So this one will be 50. And this is 25. Don't you think that with this 50 and 25, we'll be able to find the whole of this length? Irrespective of the fact that this is the only one we want to find. But you and I know that if we know the whole of this length, and we know only this one, will be able to know what is here. It is tricky, so you have to pay attention. It shouldn't be a matter of just seeing the problem being solved. You need to understand why and how certain things are done. Okay, so first of all, here is a triangle. Okay, we can help by identifying A, B, C, D. Here is X, which we want, the length of this. So this is 40. Here is 10 degrees. And this is 25. Now, let us go like we are complete beginners. This is a line. And we are told that from this to this is x. Once we say it is x, it means we don't know the actual value until we find it later after a series of calculations. Now, we want to know this. There is no way you can tell what is here if you don't know from this to this. Now, let us assume from this to this is 10 meters. From this to this is 10 meters. But this is what we want. Can we tell what should be here? No. This is like you saying, and John is 10 years old. John is 10 years old. But you want to know the age of Ali. You cannot tell this one. Why? Because there is a missing information here. In fact, this one does not even match to what I'm trying to say. Let's just go this way. This point to this point is what we want. But what if we know from this point to this point? Do you think we can still know what should be here? No, we cannot tell what should be here. But if we know what should be here, then we can tell what should be here. Now let us assume from this point to this point is 7. So if this point to this point is 7, definitely we can tell what should be here. How? Because from this point to this point is 10. This point to this point is 7. Then from this to this, it will be what? It will be 3. Because the full length, 10, minus this 7 will give us the remaining 3. So what comes to your mind now is that we need to know first what should be here. There are two things we need now. We need what should be here, and we also know the full length. So let us try to find this. But is it possible to find this? Let's see. Now finding this, unless we use this triangle. Which triangle? BCD, this one. So now what do? Let us inform the examiner which triangle we want to work on now. So we say from triangle BCD. So once you write this, you inform the examiner that all what you want to do now is within this. Now, according to trigonometry, remember, go to trigonometric videos. The first day, I explained exhausted how we can identify the opposite, hypotenuse, and adjacent, provided if the triangle is a right angle triangle. We are lucky enough that this triangle in question is a right angle triangle. Yes. Now, between the given angle 40 and the hypotenuse, between the given angle 40 and the right angle, that side is called what? The adjacent side. Paying attention, please. This is the adjacent side, and we are given this. If you want to find one length, here we want to find the angle. Here we want to find the side. In a right angle triangle, for normal circumstance, in a right angle triangle, if you want to find an angle, you expect to give you what? You expect the examiner to give you two sides, normal circumstance, for it to be possible. Now let us say here is 10 meters, here is 7 meters. Any of the two sides, it could be this and this, it could be this and this, it could be this and this. You want to find the angle for it to be possible in a right angle triangle, you need two sides. For you to find one side in a right angle triangle, we have two possibilities. If you want to find one side of a right angle triangle, it has two possibilities. Either the remaining two sides are given, like 10 and here is 6, without involving an angle. That one requires the use of Pythagoras theorem. But if you want to use a trigonometric ratio, you want to find one side, well, you need one side and what? And a particular angle, whether it's this angle or this angle. You need to understand what I'm saying here. For you to find an angle in a right angle triangle, for it to be possible, you need two sides, no matter what, for it to be possible. For right angle triangle, if you need one side, the length of one side in a right angle triangle, there are two possibilities: the use of Pythagoras theorem, the use of trigonometric ratios. For trigonometric ratios, you need one angle and one side. For Pythagoras theorem, you need another two sides. So if you can master this, no problem. It will help you in the long way. Okay, so back to where we are. We just confirmed that for us to get this, there are two things we need. We need the full length AC and DC. So the full length AC, which I suggested, for example, like this, if we get it, we'll get this. We can say the full length minus this will give us this. Now let us try to know what is DC. Yes. So we say from triangle BCD, if you want, you can have the diagram drawn again if you want. This is C, D, B, and here is 40 degrees. Here is 25. So see what I was trying to say. We need this side. For you to get one side, you need one angle, one side. For us to get this side, we need one angle, one side. So it is possible. This is the adjacent. Why? Because it lies between the given angle and the 90 degrees. So the adjacent is 25. And the side that we want to get, it is the one that is facing the given angle. So it is the opposite. So opposite and adjacent. Opposite and adjacent. It is what? It is OA. We have SOH, CAH, TOA. Which one ends with OA? OA, it is tan. So we say tan 40 degrees equal to opposite over adjacent. What is the opposite? It's DC over what? The adjacent, which is 25. We give this 1. 1 times DC is DC. Tan 40 times 25. 25 tan 40. All right. So now we say DC is, without wasting time, you can use your calculator to know what is that. 25 tan 40. Now let's see. 25 tan, straightforward, 40. So have what? 20.977. 20.977. Approximately this is 21. Because around this one to this one becomes 10, it will affect this one. So it is 21. Okay. So DC is 21. But if we know DC, we cannot find this one unless we know from A to C. And the only way we can get A to C, unless we consider the bigger triangle. So let us inform the examiner that we want to work on the bigger triangle. So we say from triangle ABC, ABC, and that ABC is this one. Here is C, here is A, here is B. Now that we are considering the bigger triangle, which angle do you think we have here? Is it 10? No. Is it 40? No. We need to combine this to give us 50. And here is what? 25 meters. So we are lucky that we are coming to use the same thing because this is the opposite facing the given angle, the adjacent between the given angle and the right angle. So we are using tan again. So we say tan 50 is equal to the opposite, which is AC, over the adjacent, which is 25. We give this 1. 1 times AC is AC. Tan 50 times 25, 25 tan 50 degrees. So what is 25 tan 15? 25 tan 50. 29.79. So we can say 29.8. 29.8 meters. So now it is easy for us now because from A to C, we know it is this one. And from D to C, it is what? It is this one. So knowing A to D now is now easy. So now we can say, therefore, for us to get AD, what do? We consider the full length, which is AC minus this DC. Minus DC. So AD, we cannot write X because we are not given AD. You and I decided to write ABCD. So what is AC? From A to C, 29.8. What about DC? 21. Then X is equal to, of course, this is 8. 29 minus 21 is 8. So it is 8.8. So this is what we have. Thank you for watching. Do not forget to follow, like, share, and comment. See my next video.